Disruptive Innovation Festival 2017, where we ask the question, what if we could redesign everything? We've got a really exciting session coming up today. We're looking into whether nature is the future of technology.
Can nature redesign the servers?
How do we know how long it is?
They've got no audio and they're coming out.
Can nature redesign?
For joining us today on day 2 of the DIF. We had an amazing kickoff yesterday in London. I'm sure loads of you can catch up on it. The DIF is an interactive festival, so we want you to be looking at the comment section in the discuss box below on the session page, messaging us via Twitter on #ThinkDiff. I will be checking for your questions as we go through and making sure that we, answer all of them. So my name is Vicky and I work here at the Ellen MacArthur Foundation. Back to the question, that is nature the future of technology? Joining me today, we have Marko Brajovic, who will be joining us on the screen. He's coming in from Brazil, and we have Richard James McGowan in the studio with us, coming from York today.
Yes, that's right.
Yes, so Marko is an architect who specialises in biomimetic and organic design, and Richard is here from Biomimicry UK. We will be hearing more from Marko shortly, but first, Richard, I've got a little bit of a challenge for you. Are you able to tell us what biomimicry is in sort of 30 seconds to a minute?
No.
The short answer.
Yeah, biomimicry or biomimetics is about looking into biological strategies to help us solve our technological challenges. Really, that's it in a nutshell. And then you start expanding on that by looking into structural forms and materials. How does nature manufacture? How does nature, biological process, communication, things like that, from chemical communication through to signalling and things like that as well.
Interesting. And so, sort of, how did you get into this area?
It was kind of a meandering story for me. I started out off interested in engineering, so naturally went to university and studied finance and development and real estate. And from that, I ended up looking into psychology of economics, so behavioral economics, and why people buy and sell basically property. And it got me very, very interested in this kind of randomness and inefficiencies of how people work, and how, as a crowd, we are actually dumber than we are as individuals, or vice versa. And that kind of led into me retraining after time, getting frustrated with the property market because people were very much reactive in how they dealt with things, not proactive and not dealing with waste. So I retrained as an urban designer. So thank you for the economic crash back in the mid-2000s, because that made me retrain, worked, and I retrained as urban design, and that kind of led into looking into ecological design and led into looking into biological systems. So it's kind of all kind of fed back to the engineering and being very much interested in aircraft and planes. So I found my old, it was a couple of years ago, I found my old sketchbooks from when I did art and design, and there's lots of aircraft that I was trying to replicate into swans and vice versa. And it's kind of realizing that actually it just clicked, and it makes sense, but it doesn't as well, because it's enjoyable just to pick up, go for a walk in the woods and find lots of different pine cones and things like that, and seeing what kind of biological strategy you can take from things like that.
Interesting. So you use those as the inspiration for kind of any ideas you're coming up with. I wanted to also pick your brains on kind of your favourite examples of biomimicry that you've come across.
My favourite one is a plastic bottle by Vitalis Water in Portugal. And the reason why it came from initial concept to actually into the market in 6 months. And it was using existing manufacturing techniques, and it was meant to align with the design of the packaging of actually Vitalis itself. So a company called Logoplast, and a brilliant design team led by Carlos Rego in Portugal, basically looked into biology. How could they reduce the weight of this plastic bottle, PET plastic bottle, as much as possible, but keep the shape and stay within those parameters set down by the client? And Carlos, a bit like me, he likes going out and standing looking at the trees outside of his office, and he was looking at how the twisting growth patterns of the tree trunks as they come out of the ground due to the external factors like wind and all those things. And he actually looked into that, and by using computer modelling, he's actually the first iteration of the plastic bottle took off 7% reduction in weight, which is great. So in 6 months, he's came from that to redesign this plastic
it's still
bottle.
got the same sort of level of strength,
but it's not finished
less
there.
Weight.
So he's continuing to. He's in the third iteration now. So they're continually looking at where can they strip away the materials as much as possible.
Yeah.
I know a lot of people say, well, why don't you use plastic?
Yeah.
But you've got to be realistic that that's still where they're working and they have to do
Yeah.
it. So slowly over time, they are wanting to speak to clients and say, right, can we move into different types of materials, or can we fully recycle? But it's the fact of the matter, it's a commercial need, and they've used that in a very, very innovative way. And it's fascinating. I like using that because you can speak to an economist about that bottle, or you can speak to a product designer or architect, and you can say it's simple, but it's elegant, it's complex. It ticks so many things, from branding, from material science, and the amount of, you don't realise how many people go into the design of a plastic bottle. And my problem was, from looking at that, I walk around and keep finding trees with the twisting pattern and the growth. It's a bit like when I used to work in property asset management, and I would constantly go around and see fire extinguishers out of date. So I got obsessed by looking at trees and seeing the different types, because that's the key thing, what I'm here to talk about. There's not just one tree that exhibits those characteristics. There's lots and lots. So how do you find the correct one?
So, okay, so almost there are so many solutions that nature has come up with, because I'm even thinking now, kind of, you've talked about plastic bottles. I can't remember who made it, but I did try a way of drinking water where you kind of popped this like blob in your mouth and it burst, and that was your way of kind of getting hydration. And I'm sure someone will message me and say who exactly it was, but kind of those inspirations from nature. But obviously you can look at the trees, you could look at the swans, you can look anywhere, and it is a very complex world out there. And so I wonder how how you can simplify it for people, or should we even simplify things? I mean, something we at the Ellen MacArthur Foundation talk a lot about is systems thinking, and like, do we need to understand the world around us better? But how do we do that? How can we simplify kind of systems thinking and complex systems for people?
I think the key thing, and I know from speaking to some of your colleagues, is not simplifying the system, it's simplifying the language used and getting that across, and how do you use it from infographics and things like that, and explaining to people step by step, one or two elements, connecting the trade-off, adding in multiple other factors, and then building it up, and then explaining to people that you don't need to consider the whole system straight away. Because when you explain to somebody, right, map out on a bit of paper an ecosystem, and you may as well just get a 3-year-old child to just draw around, because it's lots and lots of dot joining and things like that. But if you focus on one thing, what happens if you change, say, a keystone species in a historic woodland, and take that away? How does that impact on all the other things in there? And
so almost sort of that connection, sort of the connection between biomimicry and systems thinking could be just really going in at those examples and then mapping out from there.
Yes.
Interesting. And I mean, I really also would love to hear a little bit more about the work that you're developing related to artificial intelligence and biomimetics.
Well, that's something we're at a kind of early stage. It's led by Professor Julian Vincent, who's the former head of biomimetics at the University of Bath. And
I have just said biomimetics, but I'm also very aware that what is the difference between biomimicry and biomimetics? Is there a difference, or are they the same?
There's lots
word?
of different phrases. You've got neo-biomimetic engineering from Japan. You've got nature-inspired engineering, bionics, biomimetic. They're all attached to the same field. They're all doing the same thing. They're looking for innovation, solving innovation challenges by looking to the natural world. Some are focused more on the ecological design side. Some looking more sustainability, even though I hate using that word. But they're all, at the end of the day, wanting to do the same thing. And it's about we just all need to group together and work and keep pushing that way, because at the end of the day, all it is everybody's got this design philosophy. So the key thing is you need to figure out what the client or the challenge you need to overcome first, and then can you look into biological strategies that can help solve that.
Do you ever find there are kind of limitations to using kind of biomimicry to solve some of these problems?
Yeah, it's down to and I'm sure Mark will allude to this as well, is money, time, and the client. And sometimes, I mean, I just go into it as a common sense approach, maybe because of my background in finance. And if it doesn't work now, you can't just push it and say, oh, because nature knows best. But sometimes nature, we've had discussions before. It's about nature. It's continually evolving. There's remnants left over from a bygone era when it was doing those strategies before. So we used to have that with our appendix and things like that. Although they've now found it's our mini Yakult bottle. So it's a case of like saying, right, can we find out? It's one of the tools, so you speak to guys who do Lego serious play, different brainstorming, Triz, there's lots of different methods. As long as we can come up with a solution, it doesn't matter as long as, as you solve the problem. And can it make it, using less materials, improve the efficiency and things like that. And yes, obviously we have to consider the fact that we're working for clients and they're, want to increase the turnover. So you can do that two ways, can't you?
So they're saying we want our quarterly profits, and you're saying, okay, but trying to sort of tie in your ideas to kind of their framework.
I mean, that's the bigger challenge of sitting down with companies and saying, how do you do ethical investing? So it's areas we're looking into as well, investing into different bio-inspired innovation products across Europe.
I'm going to stop you there for one moment because we also have Camille in the room today, who's going to tell us a little bit more about what she is looking forward to coming up at the DIF.
Yes, Vicky, thank you. Lots of sessions coming up at the DIF over the next 3 weeks. For example, just to cite a few, on Friday at 2, there will be a session that will help you learn more about what are the most effective ways to teach biomimicry. And another one I'm looking forward to is tomorrow at 4, one about the future of food packaging, new definitions for food packaging in the circular economy. Lots of sessions, about 100 sessions in the next 3 weeks. And if you miss one, remember you can always watch it on demand on the site thinkdiff.co.
So we're bringing Marco into the conversation as well. He has been waiting patiently over there in Brazil. What time is it with you, Marco?
Here we are, 5 p.m.
5 p.m. Perfect. Whereabouts? You're in Brazil, aren't you?
Yeah.
I mean, yeah, perfect. So the first question I wanted to ask you was, what can designers, what do you think designers can learn from living systems?
Actually, there are different levels of learning from living systems. First, it's about living. It's about process. It's about evolution. And it's about basically the idea that a design result is just a moment in an evolution of a development of a project or eventually of a product. So it's not about the final product. It's about understanding the process and valuing the process of the development of an idea. And the second word, it's about systems. So we're talking in a systematic way. And when we talk about systems, we talk about interrelations, we talk about community-based development, we talk about resiliency on different levels of system and subsystems. So it's about understanding that nothing is disconnected, that everything is connected to everything, as discipline, as a design process, and as a result.
And so, sorry, you carry on. I'm jumping in here.
No, please.
I was going to ask as well, so within your design process, obviously biomimicry is a huge part of what you do, but do you again find limitations to using biomimicry as inspiration?
We are inspired on different levels when we work. We can be inspired on a more superficial level, still fair enough, about beauty. We can be inspired on a deeper level when we go in contact with finding strategy solution like proliferation system, how structure stands, how things works in nature, and how things work on a systematic level. So luckily, we collaborate with biologists to understand deeply processes and natural strategies. So when we think about being inspired by nature, eventually you see a leaf and you say, okay, hey, I'm inspired by this leaf to make my roof, but it's not about the shape of a leaf. It doesn't need to look like a leaf, your roof. Actually, you can be inspired by the strategy, how this leaf is cleaning itself, how it works by shape, how it have a metabolic distribution system of veins, etc., etc. So you need to go deeper in processes more than in shape. And so that's when we talk about biomimicry, biomimetics, as Rich said, there are so many names about it, and there are thousands of years of inspiration in nature. I think it's the first step is to make people aware of the intelligence of nature and of the technology of nature. In fact, we are talking about the highest technology that we can find on this planet, way higher technologies that the industry have ever developed. So there is still no any evidence how photosynthesis work, or so many natural processes. So I think that is not so much about limitation, is much more about sensibilizing the public, the wide public, to the importance of understanding nature as a designer. No? Like Giannini would say, 3.8 billion-year-old designer. So how we can learn from that designer.
And you mentioned sort of biologists there. Do you work quite closely across fields with biologists and people that are, researching nature, or how do you connect with people, across, looking at these things?
We do collaborate with biologists in some moments, in some fortunate moments where our clients are keen to that. We are a commercial company. We developed scenography, product design, architecture for our clients. So we first need to seduce them about the importance and about the higher value and result it can be reached through project inspired by nature. So, for example, in this case, is a lamp. It is a design for a pretty luxury product design brand here in Brazil, and actually they were not so much concerned about where ideas come from, and we were analyzing the growing process of grasses, and we parameterized this growing process. Actually, there are plenty of software available today that can mimic some evolutionary principles as some growing process, and you can simulate that on a computer. So this lamp, for example, was not designed, it was growth. It was not designed by Cartesian parameters, by 3 axes, or by hand, by a gesture of a designer. It was growth by a process, so what's programmed. This system was programmed. There were more than 3,000 lamps growing in our software. Only this one stand. So we built it, and actually we didn't print it. We built it with a handcraft, traditional handcraft knowledge here in Brazil. So that's another point: how to connect handcraft with digital. With this digital handcrafting, even when you don't have tools like high-tech tools in Brazil. Yes, we do need biologists in order to understand some more complex processes. For example, in this project, we were inspired by the sea star. Our architecture had similar problems that the sea star had: higher pressure from the top as a sea star, and lateral side pressure movement like a sea star have a currency underwater one. So we let's say emulate some basic proportions and measures in the pneumatic system of the Brazilian sea star, and we scale it on a higher level, so we could get this shape responding to similar problems, and it's a 400 square meter 9 meter tall structure that is standing by itself just with pressure of air, and is standing strong winds of subtropical forest.
So you mentioned there that you grew your lamp, and I wondered whether sort of digital tools are shifting design into a new era, and whether you think this is the case.
I believe digital, as it comes from the Latin digitus, it means finger. For me, digital, it's really close to the handcrafting. I spend more a year living in Costa Rica with indigenous community, and I often visit the indigenous community here in Brazil, in South America. Actually, I came to Brazil 12 years ago from Europe. I'm from the Mediterranean, so I was really fascinated by the forest, the Amazon forest, and that's why I was used to stay here, as I thought, okay, hey, I'm in the biggest laboratory of the world as such biodiversity, so I can learn from it, from different ecosystems, different biomes, and different organisms. But I came from a background as an architect. I have a master's degree in digital technology and another master's degree in biodigital architecture, in genetic architecture. The name is kind of big, but it's just about natural strategy applied to digital design, digital processes. A little bit close to the Architecture Association School, you have really evaluated in this area in London, in this kind of research, is particularly the emergency group. So that trend that architects learn from nature about processes and about how apply those processes in a design process, it's something very, really new. And but on the other side, it's really crafty. It's like working with tools. So this relation for me between digital and natural, it's really a symbiosis, and it's a way to overcross an industrial era of a mechanical perception of a design, of a perception that brought to our industrial revolution and our industrial architecture that we are still using and living in it. So I believe that to overcross that moment and to finally get in the 21st century, the digital and the biological come together. So we are talking about biotechnologies and how that come to developing of new biomaterials, of a new organic process of designing, not only as a typology or let's say as an attitude in architecture and design, but in an intrinsic in a development in a process as much in a fabrication or in growing architecture instead of building architecture. So I believe that digital technology and architecture and design were never so close than nowadays, thanks to a perception of an organic process in understanding nature as a designer, in understanding its own strategies and how to apply that and how to parameterize that in a design process.
That's very interesting, because you go back to even Frei Otto was doing a lot of that work before computer-aided design came along. So he was doing it manually by doing measurements and looking at generative design and tying in the parameters. And it's very interesting from my perspective, when I've done giving lectures in the past, that you don't allow them to use computers, and it slows down the process, and you show them how if you change one parameter it impacts on the rest before you allow them to get onto the computers. Because until you have awareness, like Marco was saying, of tying in, you know, how things build up and are growing, you can't let them on the computer, because if not, you don't want this CAD monkeys. You know, you need James Dyson, Jonathan Ive saying you get the best graduates coming through his door, but you can't give them a job because they don't know how to make a model. You know, you still have to go out there and get your hands dirty, get your bits of paper, do doodling, get all your charcoals out and things like that, because that's your creative thinking process.
Yeah.
The technology is there as an enabler, not to take away from that.
And so, I mean, I know that we very briefly talked about the technology that you guys are involved in at Biomimicry UK, and I wondered what you thought about sort of the digital tools and the kind of artificial intelligence side of things that you're working on. You know, I think everyone here the audience would be really interested to find out a bit more about what that is.
Well, what the key is working at taking when we look at a pine cone. I'll use a pine cone because I've got a lot of them. Why are we looking at that biological strategy? There's thousands and thousands and thousands of biological strategies out there, and from using different species, and there's a lot of convergent evolution where they're following the same repeating patterns, and it's about finding the right basically trade-off between these strategies, so you can actually find the minimal contradictions, the negative trade-offs that you've got between the two to actually help you solve the problem. So instead of a database, which is
It doesn't like the pine cones.
Oh, the ghosts are coming out. So instead of a database, which a database is basically a catalogue of things, and the designer has a vision of what the database is wanting to do, we're working with complex relationship modelling, and from that you'll actually see emergent patterns coming out, and it will start over time. The more and more information you build in, you will start seeing things. It will take away kind of the human bias, because what we're finding is people saying, hingeless mechanisms, control system, based on the pine cone. They look at that. Why are they always looking at spider silk for strong materials? Because that's what they see. Or how many students are now going to go and do projects based on what they see from watching the Blue Planet 2? Now, it's not saying it's a bad thing. Yeah. It's a good thing, but there might be a better solution. Better solution by looking into these machine learning AI, so whatever we want to call it, that it's going to be developed. I mean, we're talking 5 years down the line before it gets there, because there's lots more. There's lots more companies that we're speaking to in research institutes. I'm kind of the translator between the scientists and the designers in my head. And the joke is with the Julian Vincent, where one's bindweed and one's honeysuckle, because one goes one way and one goes the other, and we finally actually agree on something. But that's the thing, because we were talking about, it's the translation between everybody. And
so almost giving someone the best solution that they may not be aware of, or they may not know where they should be looking, by just giving them that sort of information at their fingertips.
And that's the big thing, as Marco alluded to, is sometimes the speed that a client wants something out there, and it might just be, right, it has to be this biological strategy, but hopefully by developing these systems, that will mean you can have a greater load of these strategies available. Load is a terrible word, to actually give to the client, or you to use in your design to actually help improve it more.
I'm going to also bring in a few questions. We've got some questions from the audience. On the session page, someone has asked, does growing a material use less energy than other methods of materials formation?
Can I show you the graphs that I prepared, if that's all right?
Yeah, absolutely.
If we cut Marco off.
You're not being cut off.
Not totally. But anyway, this was about our hierarchy of needs, Maslow's hierarchy of needs, what people need and want in life. Obviously, the key thing now is actually people want Wi-Fi as a key signifier. We'll skim through that. We, as a human species, ties into the pine cones, as we see patterns and things we don't necessarily should be there, from looking at clouds to seeing, the Messiah on a piece of toast. In this case, it's a Fibonacci sequence of...
is this something that's going to be in
the ruler of the free worlds, whatever, the Chihuahua that's on his head.
And that's going to be in your new tool, I imagine, if people did want to base something
on.
Yeah,
that'll be the error page. Yeah. So the key thing is, what we're finding is, how does nature problem solve? So these are basically taking the Triz contradiction matrix. So you're looking at changes in substance, how we change the structure, both in biology and technology, from space, using information, energy and time. And the great thing is, you find is, hopefully they'll play at the same time, is on technology in the left at nanoscale, lots and lots of energy. Whereas you see in biology, energy, if you keep watching it, is very, very small. Energy is very, very hard to come by. Why do giant pandas spend 99.9% of their time eating? Well, mainly because the energy is very, very low, low calorific content, the same way, rhinos and that as well. So that's the thing, is we can look at these low energy processes. How does the the natural world, manufacture ambient temperatures, and then have it, be able to be broken down. So pine cone's a great aspect, additive manufacture, it grows bigger. I always use this as an example compared to my son's, manufacturing process of this lovely little Japanese toy car, but how many materials is there and how much waste is lying on the floor?
So almost saying, this shows us here that actually biology does it from an energy perspective, and it seems like on most of these scales does it better than technology. Are there any that actually technology is doing better than biology?
Well, if you look at, have a look at nanometers. It's not a case. It's a case about focusing on the key thing here, and the key thing is looking at taking the energy processes. I mean, at the end of the day, that's the key thing that we need to start looking into, is energy, and also the amount of materials that we use. In the natural world, they use the lightest materials. When you look at the basically the chemical elements chart, they use the lightest. We like to use lots and lots and lots. And I think from like the packaging plastic industry, it's there. 350 different types of material are used. And then you speak to these packaging guys and they say, right, it's great to recycle, but you got the big companies want the virgin material kept in the market. So they make it harder. They'll stick two plastics together and make it harder to recycle. So it's about how can we tackle those things.
Yeah.
I know that ties into some of our talks.
Look at
You guys
learning from the
talked.
solutions
Yes.
that biology has brought up, and we know that the material is strong and can be broken down. I'm going to stop you now because I know that we've also got another question that's come in from Alice saying, look at us. We're surrounded by smart technology that allows us to speak to people on the other side of the world. We live in houses that keep us warm. We can access food grown elsewhere. Very few people have to break their backs to work. What's wrong with human ingenuity that means that we need biomimicry? And I might just get Marco back up on the screen, if that's all right. I mean, Richard, feel free to jump in as well.
I will.
Marco, did you catch that?
No, but could you?
A synopsis
please
would
repeat
be
again?
is
Was a
that
kind of noise.
is humans have done so much. We have, from houses that keep us warm, smart technology where we talk to people on the other side of the world. It's kind of saying, actually, what's wrong with human ingenuity that means that we need biomimicry?
I didn't get the question. Sorry, it's kind of noisy.
Oh, that's all right. I might go to Richard for this one then, and we'll come back to you and when there's a little bit less noise.
It goes almost back to what I said before, that we're using our resources at an astronomical rate. And we're not solving all the problems perfectly. We're creating things at the waste. If people used to watch Mad Men and they'd see them having a picnic and then just chuck the rubbish away, because in the natural world, waste is a resource. It's part of, if anyone's interested, you look into kind of the rules and laws of thermodynamics. Energy is always transferred over. So it's using that key element. Nature does waste, but that resource will eventually get tied into it. So we need to start thinking, does nature actually do things better? Yes, in some respects. So let's emulate that. The talks yesterday, people were talking about economies mimicking biology. Well, actually, no, you do need to look at psychology as well, because it's not just biomimicry, it's biophilic design, ecological design, and just start thinking, why did we get away from looking at the natural world? We invented fire, industrial revolution, and then we actually did get lazier because everything was, agglomerated together, and we started drilling. We found this easy way of, fuel economy. Look at America, with how much that little that they pay in tax for their petrochemicals compared to the rest of the world, because it's there and it's abundant. What appears abundant and it's controlled.
And almost the worry, we don't. So kind of saying that actually, yes, we have done a lot. We have a lot to learn from nature and the natural world as well. But we need to be smart to know what to pick, and what to leave, and what's evolved because it was a need that makes something stronger, and what's evolved because it was left over from when something was crawling around in the slime.
And the difficult thing, and something Marco and I talked about last week, is it's retraining engineers to understand that you can get away with things that are non-rigid and flexible, and will break, self-repairing, with emergent properties and self-organizing. And it's that scary thing to do. And it's not even just talking about this for biomimicry. He's talking to engineers about, street trees and things in green infrastructure. I remember speaking to the head of landscape architecture at Arup, and they were saying the hardest thing in the engineering companies explained to them what the benefit of putting a street tree in is, instead of like a hard engineering solution. So it's getting those mindsets shifted. And that's the thing. So to answer the question in a long, convoluted way, are we the smartest?
Yeah.
Yeah. I don't think
we are. That is a
Yeah.
question. I mean, as you called out Blue Planet, you learn about the dolphins and these amazing animals that, would they be similar to us if they had thumbs and could make tools or whatever it was? But
According to
are we the
Hitchhiker's
smartest?
Guide to the Galaxy, it's the mice are the rulers, and then the dolphins are going to fly back into space.
Yeah.
So
No, we've got another question that's come in, and actually, Marco, what do you recommend designers should read or do to stay current?
That's a good question, actually. I believe what they should not do eventually, I don't recommend reading books about design and architecture. I believe more proper would be to understand more about philosophy, anthropology, biology, and to understand more about sciences. Nowadays, in such global collective psychosis, it's difficult to stay away as well, and to try to be genuine and to find the origin of your ideas out of the mainstream tendency and no, star architects and particularly in design about blogging and searching what are the latest trends. So I believe that our disciplines as architecture and design, they are humanistic and they're organic, so they need to learn about principles of human nature and the nature, organic and inorganic nature behavior in order to understand how to watch the design as an ecosystematic way more than getting seduced by trends that happen often. It's inevitable. We have this problem here in our office. Sometimes our architects actually get finding, oh, this is really cool, this is really nice. So it's easy to be seduced by form, and to be seduced by beauty, it's fair enough. Nature do it all the time, and it's a great strategy, and it's a great strategy to get attention, but that you need deeper levels. And I believe that classical knowledge and learning about sciences is fundamental. I started a few years ago to learn about biology, to understand it more, and there is absolutely a huge world in front of me that I don't understand, and I'm fascinated with. And I believe to keep yourself as a child in getting surprised by the world and by the phenomena that surround us, it's really magical, it's really inspiring. Yeah. So what not to do, again, is not to get obsessed by our discipline as a profession and how you will live from it and how you will be specialized once specialization as in an ecosystematic way is not actually the proper way to design.
So almost we're saying throw out the rule books, go to your lecturers and say, I'm not reading that, I'm going to go to, sit in on a biology lecture, sit in on a philosophy lecture, go and make some friends in other disciplines and sort of keep things, be as inquisitive, childlike and sort of opportunistic as possible. Yeah,
I totally agree. I mean, read science books. I'm currently reading about the 4 laws of thermodynamics. I'm telling students to go and read different things. If you're a designer, you're a problem solver. So if you can design a building, you can design a suit, you can design various things. I've trained in urban design. I'm now looking into airports, packaging companies, coffee and tea manufacturers. And it's a case that's fascinating because it's suddenly realizing actually opens my eyes up and I can focus on things are completely different and put fresh eyes. And we're doing that with our looking into the healthcare for racehorses as well. The sad thing is I can't actually ride a horse, but still.
Not yet.
Not yet.
Can be on the list.
What's the front? What's the back?
Yeah. Marco, I wanted to ask as well, you talk of sort of having a positive relationship with the environment, and I wanted to ask sort of what that means, and have we lost touch with the organic world?
It's inevitable that we living in a big cities, in metropolis like London, like Sao Paulo, with almost 20 million people, our relation with that kind of idyllic imagination of nature, it doesn't exist. But on the other side, everything is nature. If you start to understand that we are nature and is not this exotic place, this Eden that we have to visit and is an untouched virgin nature, and then we come back to our everyday life, that's a kind of really religious way of seeing nature. Once I would really prefer to understand it as more integrated system and behavior of life. Actually, our civilization is built by culture that follow the same forces of nature, and our everyday life is in relation with nature and with our human nature as part of it. So lately I start to think about that internal nature that we all have, and sometimes this tragical wish to search about the hidden nature outside, and sometimes is about understanding our nature, human nature as a part of it. So maybe it go kind of holistic, but we could easily now define the best seller practices, how to be in contact with nature in everyday life, to have a little garden, to go to the fields, and this we all know, and this is like common. But I'm wondering, what is this internal peace, internal nature, internal way of getting into contact with nature, even if we live in a big cities, even if we don't need to, or somebody don't have a chance to get in physical direct contact. I'm kind of lucky to be in Brazil, as few hours from here I can get in a really subtropical untouched forests, and that's what we do almost few times a month, as with our creative team, with my kids, with my family, and that's a way to build a sensorial relation with nature. So I believe we have this multisensorial relation with nature that passes through our senses, and we have a kind of more subconscious relation with nature, and they both can be triggered, and they both have to talk. So I think the two best practices would be to be able to connect your wish and your sensorial relation with nature that you see around you, that touch your senses, and with your internal nature through meditation, for different practices. And I believe that's a way of being better humans.
Yep, so we're all going to leave here today, get into nature and do a bit of meditation. One more question for Marco. What are the most exciting projects you're working on or have worked on?
I will go back maybe just once to your question, if it's not a problem.
Of course, yeah.
About positive relation with, I had a slide that I think could fit in.
Perfect.
And
this is where technology.
And I'm sorry, Rich, to take a little time, but
we're talking about humans and our way with technology, and you see here today are perfect.
Yeah, so this is our place. We used to go to stay in nature with making our workshops and to connect with the environment. And it's a ultralight architecture we developed that touched the earth in a pretty gentle way. And it's an anecdote of it's a really simple shape, but it's not so much about shape as much about these diagrams I would like to show you, because it's about our way of perceiving our internal and our external nature. You can see from left to right, you have a centralized system, then you have a decentralized system, and then you have a decentralized and distributed system that is a network, actually, that it's one of our biggest achievements maybe in the last digital era, of being able to not centralize. And I believe is this ecosystematic era that is the last drawing, that is a relation human with nature through the capacity of understanding this collaborative system, like a collaboration as a forest work. It's a huge community, as understanding that we are part of something bigger. So from left to right, you can see an evolution as well in our capacity of organizing our society, from a really centralized society, power top-down organization that comes to our architecture that is based on pyramidal structure, still on distribution of vertical forces, where gravity is the main concept of our architecture in the last 8,000 years. But before that, we lived in the era of fiber-based architecture. So we can go back to Paleolithic and Neolithic periods, and we were already, as humans, be able to weave architecture and not to build architecture. So a kind of that maybe 10,000 years, even before the agricultural era, around 20,000 years, we were more organic related to architecture than nowadays. After agricultural era and after top-down structural systems, we are based in our society and in our architecture consequently, because architecture follow the forma mentis of our society and vice versa. But what is the architecture of the next era? What is this connection with nature in a systematic way, and how the architecture will represent that? So going back to your question, this relation with nature, it comes out from our everyday things, not how we see, but what we do, how we work, in our little perceptions of our surrounding.
So one more example of an exciting piece of work that you're that you want to show the audience would be great.
Yes, the last project we were working on, and I'm really excited, as was shortlisted shortlisted to What Design Can Do event of the Climate Change Challenge. We were one of the shortlisted listed groups that participated, and we invested lots of energy in this challenge. Actually, I'm a co-director of the Architecture Association Visiting School Amazon here in Brazil, together with Nacho Martin from the Architecture Association School of London. And this year we manage our students to participate in this together in this challenge, and we developed a project during 9 days of immersive process in the Amazon rainforest with a multidisciplinary team from different countries and different professional, not only architects and designers, and we came out with a result that was shortlisted, and we are really proud. And like always, what I most believe is interesting to share are the processes more than results. And so I would like to share this short video of 2 minutes video, and it's subtitled in English, about how we get to our final result through observation of local communities, through observation of local nature, together with Alessandra Ruggio, biologist from Biomimicry that Rich know well, and she helped us in understanding how nature solves some problems, particularly in this case how nature float, as we were designing a floating architecture. So the combination, it's an integrative system between how local community behave, how nature behave, and our design process implemented that together with the student.
Great, so that video should be coming up.
Sono, eu tive que sair de dentro, né?
Cada ano a gente sente que está ficando mais quente e a gente sente também as plantas, os cajueiros que davam bastante cajus bonitos, agora eles não estão como eram antes.
Uns 2 anos, eu acho. Adoeceu meus 2 filhos e o meu genro. Tudo com a dengue.
Marco,
Okay.
thank you so much for showing us that. Great to see it all in action. I know that Richard has got a very short video that he'd also like to show quickly, but that was really, really inspiring. And I hope that all our projects, you know, I'd love to be heading over to the Amazon to solve some of these huge issues soon.
Yeah, my last point is we keep talking, I think we touched on a lot of, is energy transfer. Energy never goes away. One of the key fundamental rules of the universe. So everyone likes ice cream, and when you eat food, the Krebs cycle breaks it down and gives you energy. But the key thing is people always say energy doesn't go away and it doesn't, the energy was only transferred. But the key thing I always find is actually, does it true? When you look at actually my son, you put energy in, but the energy seems to keep going and going and going. So my key takeaway for me is actually, this is my artificial intelligence system here, and the way his brain is actually interpreting when he looks at, he remembers, as he's learning to speak, he'll remember seeing a kite and attached it to an ice cream to the beach. And that's kind of my, you got self-repairing, kids fall down and the material regrows. itself and that things like that. And that's my kind of key takeaway is actually if you look at children and how they're actually learning and developing and experience the world around them, that ties very much into what Mark was saying, continue playing and learning and not and always having fun.
And I mean, that's a super positive note to finish on. So go out there, have fun and experiment and be inquisitive. Thank you so much for watching this session. You can find out more about Richard and Marco on the session page. We may even be able to answer any of the questions in the Discuss channel and follow up with those afterwards, because I know that we haven't answered them all. And really do tune into the rest of the diff. There's so many exciting sessions coming on, and thank you for watching.